All right, like I said, today we're going to do sensitive natural resource mapping. To get started here, I have a blank session of Civil 3D, nothing open at all. I'm going to go ahead down to my drawing templates and create a new drawing. So I'm going to right-click on my template carefully here, make sure I'm getting the right one, and hit Create New Drawing. Sometimes I've done that and I've got the electrical template, and you'll see it right away once you get the wrong template. So I can close this drawing 4 that was open by default, and I'm set to go. So I'm just going to do a save as. I'm going to save this drawing under my project on my C drive. I have a test project set up or a training project set up. And this is class 11. It's establishing sensitive natural resources. And under there, I'm going to make an exhibit. So, typically this would be under plan sets, exhibits, but it's going to be its own standalone drawing, nothing else in it. It's going to be, L, job number, EXH, dash, whatever. I call this sensitive SNR for sensitive natural resources. You can name that however you like because it's an exhibit. I'm going to hit save and save that over top of what I had there already. From there, I'm going to XREF my existing conditions base file in. So bring up my XREF command, hit attach from Vault, and then I have my existing conditions file here. So go ahead and bring that in. Hit OK, and do a zoom extents. So I think one of the most challenging parts of doing a sensitive, determining your sensitive natural resources, or for now I'm going to refer to SNR, is really your slopes. Everything else is pretty straightforward. I mean, it's vegetated area, wetlands, so on and so forth. And if you're not familiar with what I'm even referring to with sensitive natural resources, let me pull this up here. It's an NPDES permitting requirement, and these are features in the environment that the Department of Environmental Protections is looking at preserving. And it's really all about filling out this sheet in the NPDES permitting worksheets. This is worksheet 2. Worksheet 1 is just general project information. Worksheet 2 is sensitive natural resources. 3 is, some credits. And then 4, we're going to really focus on this today of how to fill this out easy with the software. This is where you determine your NPDES volume. So if you're connecting and you do this already, this will suit you just fine. If this is something you've never done before, well, hopefully with this training or this class, next time your project manager comes in or an engineer you're working with and he says, yeah, we got to do this part, say, hey, I know how to take care of that for him. I'm sure he or she will be very glad that you've learned how to do this piece of the puzzle, because it's not that easy to get all this information into these tables. So looking at here, we're looking at water bodies, floodplains, riparian areas, wetlands, woodlands, natural waterways, and slopes. When a lot of these areas overlap each other, so you have to prioritize them, and typically the priority goes from the top down. That's what I've been following. I don't think there's very clear direction. Check with your engineer, or if you are the engineer, on how that wants to be done. I've typically, like I said, go from the top down from priority and listed my areas that way, because a lot of times your riparian areas and your wetlands overlap, so on and so forth. Some people will value the wetlands at the very top, up near water bodies, and above floodplain or riparian areas. I can understand. I think I've actually done that a couple times where my wetlands would actually be up here and my floodplain or riparian area would go down one. But it's all about filling out this table, and you do have to have a priority list. So let's go back to our CAD drawing here. And here's our project. So like I said, one of the hardest things is determining these slope areas. How do you know what area of your site is between 15 to 25% or 25% plus? Well, we can use the software to help us do that. So to get started, what I want to do is data reference in my existing conditions or my surface file. Temp project. There it is. Okay, good. Just had to do a refresh. So I have my surface file here. It's my 11 EG because this is class 11. Right click on here and hit create reference. And I'm going to bring this in as we always talk about. I already have the contours. I don't need to see it. I just need this in here for data purposes, so I'm going to always set that to no display. Hit OK. Hit OK again. So that surface is now connected. You really don't see anything happen on the screen, but you do see it over here now in the prospector. So when you expand that surface, you know, the contour area that you see on the screen is that surface that I just data referenced in. And really my NPDES permit boundary or my site area is going to be this green property line. You can see it go down and around here and so on and so forth. So I need to shrink this up, or that's my initial NPDES permit boundary. So you can see some flaws right off the bat. My surface isn't large enough for my NPDES permit boundary. We're going to take care of that here in a second. And I need to be able to bind this surface, put a boundary on it for my permit boundary. So how do I do that? If I look under my my surfaces column here, there is no, since it's data reference, there is no availability to add a boundary. Well, we can get around that by simply creating a surface in this drawing called 11, SNR, since it's natural resource. It's only going to be in this file. And I'm going to set the style to this, and we're going to do a slope analysis with this. So we're going to set it to HRG analysis slope. So that would be the style you want to use. Okay? So give it a name and give it this HRG analysis slope. Hit OK. Hit OK again. So again, nothing happens on the screen because this surface is blank. There's nothing in it. But I want to add something to it. So I'm going to right-click on Edits and go down here and hit Paste Surface. And what I can do is this newly created surface, I can actually data paste in my data reference surface. So my 11 EG surface, I'm going to paste into my 11 SNR. So hit OK and adds that data to it. And you can see I get something shown up under my screen here, all the slopes of the surface. And it's just a hodgepodge, and we'll refine that later. But now what I have is now I have a surface in this drawing that I can add boundaries to. Okay? So before we add the boundary, why don't we refine this slope criteria. So I'm going to right-click on the surface, hit Surface Properties. I'm going to come into the Analysis tab. I'm going to switch this from elevation to slopes. And then I'm going to switch this to HRG slope area for my legend type. Really, there's two ranges I need to look at, as you can see on this ENS worksheet. You know, there's 15 to 25, 25 plus, okay? So, you know, in the range number, I'm going to change that to 2, and I'm going to hit the drop-down arrow. Now that will set up my ranges. This plus number can be something crazy. 8,000 will do it for this project. That could be up to 1 million. It doesn't matter. Some really, really high percentage. That's the infinity number. We're going to change this to 25, so this would be our 25 plus, you know. And we're going to change the max number here to 25 and the min number to 15. So hopefully that makes some sense. You got slopes from 15% to 25 and 25% plus. They're going to be these two hatch patterns. Let me change those up a little bit. I'm going to say those are green. I'm going to say these are yellow. Try that again. That's yellow. There we go. Hit OK. And instantly you'll see our surface now has hatch patterns for all these little slope variations. Now, depending how your surface is built, you know, crap in is crap out. You will get a good depiction of the slopes out there or not. This is probably not the best teaching example because this surface was made from contours. And as I always say, you should never make surfaces from contours. It's like making a copy of a copy. You'd say, well, why'd you do that? You talk out both sides of your mouth. Well, that's the only thing I had in this project. It came from Arial back in '98. We didn't think to ask for the DTM data, so we made it from contours. So that's why you're going to get a lot of this irregularity. Quite frankly, for this class, I'm going to be okay with that. At a minimum, you can use this now to trace around your different slope areas, maybe combine some stuff together and get the areas based on that. But what we're going to actually use what the computer pumps out here. I would say it's more detailed than what we would do by hand either way. But I still have an issue. I have hatching outside of my permit boundary. So let's add our permit boundary in. And for time, I have to bring that in. So do a W block here to have that. Slope boundary, yes. Explode it. All right, so I've already drawn up my permit boundary, and since it's sort of arbitrary where your permit's boundary is going to be, depends on the project, but in this project it is talking with the conservation district where I'm going to have my permit boundary. It's sort of this massive farm, so we don't want to use the whole property. So we're going to use the immediate area where the project is. I have a boundary, hopefully you can see it on the screen, goes down to the creek, around, up, across here, and back down again. So I'm going to add that to our newly created surface. So I'm going to right-click on boundary here, hit add. Since I already had that boundary selected, I don't have to go ahead and select it again. I'm just going to call this outer. And I'm going to keep this non-destructive, it's going to add the boundary type outer as non-destructive break line. So it's going to trim off the surface right on the edge of it. If I had curves in it, I would set this to 0.01. It doesn't hurt to do it, but if you don't have curves in your boundary, it doesn't matter either. Hit OK, and you'll see that will pull that hatching into a smaller area. Okay. So now that I have that, I still don't really have an area. It's a pretty picture, which I do need. I do need a pretty picture for the conservation district, but I ultimately need an area, so I could set it to the back. Saw that real quick just to get a see-through there. Ultimately, I need an area for my chart, so I'm going to come up to my Civil 3D pull-down, and I'm going to go to Surface, and I'm going to go to Add Legend Table. Add Legend Table. So I have to look down at my command prompt here, and it's going to say Select Surface. So I'm just going to hit Enter, and I'm going to just pick my 11 SNR surface. Hit OK again. And here I have a bunch of options down at the command prompt. I can add a table for elevation, slope, contours, user contours, watershed. I'm going to do slopes. Hit S for slopes. Yeah, dynamic. I like dynamic. That's a good word. And place that. And now you can see I have a little table, and maybe I show it or not, that shows me the percentages and my area within that. Now, be cautious with this table. I've noticed a little glitch in the software. That area is correct, but you would assume it said dynamic, right? That if I take this boundary, bring it up here, and move it around like this, which could happen, then I have to rebuild my surface. So it gets in more colored area, more triangles. You would assume this table would automatically update. It doesn't. I think that's a glitch in the software. So it does, but you have to go back and hit Add Table, Add Legend Table, pick the surface again, and hit S for slope. And as soon as I hit S for slope, watch these numbers up here, and hit dynamic again. As soon as I hit or went through the dynamic part, it changed. So I'm basically going through the procedure to place a new table. I don't have to physically place a new table. It does at that point update the existing table that's there, so I can hit escape and I'm good to go. But do watch out for that. So that's a simple way to get your areas. It's basically adding up to all these little yellow triangles. Now, if you're saying, oh, I don't like that mark, I want, because it's really hodgy-podgy through here and I want to, make a more smooth boundary, like say that, oh, well, this is generally my 15% zone. Well, then you just use the little colored triangles to trace around, and then you're just doing it with polylines. But this does give you a method to at least do that, and also you could take the areas right from that. Even picks up, my my little berm here, or not berm, but the shoreline here, the creek that runs through the property. It's getting all that area. If you didn't want to include that, you could pull that out just by bringing that boundary back. The rest of the areas, there's no real special tricks. I'm just going to import those in here. The rest of the areas for the project, there's really no special tricks that the software is going to amazingly tell you in a couple clicks where it's at. It's essentially tracing around. This is my wood line. I traced around that and keeping those priorities straight. Here I have a water body, then I have a floodway, really it's wetlands from here up, so which takes precedence in this overlapping zone. That's where you have to really make sure you're doing before you get into this too much with tracing these hatch boundaries out. Once you have these hatches here, a lot of people save the outer boundaries. You don't really need to do that. If you just click on a hatch boundary, you can look in your, or any hatch, you can look in your AutoCAD properties and it lists the area of that hatch. That's a new feature in 2008 and up. You can also do the same thing for if you have multiple hatches. As this wood area is multiple hatch patterns. If I look in that, it's going to tell me the area and then the cumulative area. So if I selected, this is all one hatch technically, but if I had 3 or 4 hatch patterns and I selected, individual hatch patterns, I selected 3 or 4 separately, it would show me the cumulative area in square feet, and we could pull that out. I do have a question here. Can you do a smooth surface to get cleaner triangles? Yes, Brandon asked, can you do a surface smoothing to get cleaner triangles? Yes, but not for this project because I made it with contours. If you do have a real surface that's made by like actual survey or aerial from an aerial company, and whenever you guys are getting aerial from aerial companies, you should always be hitting the PMs, or if you are the PM or the engineer, to get the surface data, not just the contours. All aerial firms do their surfaces nowadays with computer modeling. So you need to get the DTM mass points and the break lines from them. They never send it right off the bat. You always have to go back and ask. But yeah, that would, to answer your question, if you would do a smooth surface then, you could, and there's a post on how to use this. Just type in smooth surface on the CAD management channel. That would smooth out, give you smoother triangles, because this is physically reading the triangle slope between these two contours. So another way to look at this, if I right-click on this surface, hit Edit Surface Style, and I turn on the triangles in this view, you can see why it's shading those areas. It's shading the specific triangle. See, there's a triangle here. Well, this specific triangle is above 15%. So that's falling in, or above 25%. So that's falling into the 25 plus, but these are not. And you can see what you get when you create surfaces from contours. It triangulates between each contour because that's all it has to go by. So you do get degradation in your data and in your model. So just try to avoid it. And a lot of people say, well, we got it from aerial. It's like, that's not an excuse. You should be getting the information from the aerial. It's like, well, the PM didn't do that. Well, did you ask him to? Those kind of things. So anyways, not to stick on that too long. All right, so that's a piece of it. Really, from that point forward, you're just taking those areas and punching them into this table, okay? So it's really not rocket science, right? Civil engineering, it's just dirt. Punch those areas in. If you're going to have any areas that are protected, so that means you're going to put a fence around them or an easement around them, then those would be protected areas. If you're going to protect them, from what I understand, from at least down here in Harrisburg, you actually have to physically do something, put covenants on the deed so you don't go in there and mess up the wetlands, so on and so forth. So typically we're not protecting any of that stuff because it adds extra cost to the project unless we really need to do that. You can take credits here for your minimizing soil compaction, so on and so forth. So if you are the engineer, you know what you're doing here. Take a whack if you're a CAD technician, talking to your engineer and figure out what they're going to do for this. And you get down to a non-structural BMP credit. And the next piece I'm going to focus on is really filling out all this data. This is our existing cover analysis for the whole NPDES permit area, and this is my proposed cover analysis for my whole NPDES permit area. So let's take a look at that. Okay, so to get started with that, I'm actually going to make a new drawing because we're going to start using some topologies again. So you've probably seen this before, and you'll see it more and more. And with that, I don't want to use the Civil 3D template because that has a lot of overhead that comes with it. I'm actually going to use this HRG topology template drawing. So I'm going to hit Create New Drawing off of that. And I'm going to save this. And for the CAD standards, it's going to be L, job number, topo. It's a base file just like any other base file. I'm going to hit save on that. Okay, and I can close my old drawing here. I'll just close, I'll check it in later. All right, so in my topology drawing, what do I want to get started with? Well, you need, to do any kind of stormwater analysis, and you can look on here, you need three things. You're always going to need the area of interest, which is our permit boundary or our MPDS area. You're always going to need the soils and the cover types, the soil types, sorry, and then you're always going to need a cover type. So it's cover, soils, and area of interest. Those are the three things, all time, every time. And you have to break it all down, which is a very tedious task, especially if you have a big permit boundary area. So let's get started on how to break that down. Again, I'm going to XRF in my existing conditions base file. And here's my site. I'm going to start off with bringing in my soils. How do we do that? Well, I'm going to draw a rectangle. And I have this little sheet legend here so we don't overlap profiles in different drawings. Here's my little twist angle line. So I just really wanted to bring in that site because I want to pull in this rectangular area. I'm going to unload my XREF. A little XREF dialog. And then I'm going to type in map W space and turn that on. All right, so this is the Civil 3D map tool pane, and I've noticed here if you start a brand new drawing, you can see it's sort of, these should have items under it. Just like a lot of other things in this program, if you do a revert, which closes and opens the drawing, then they show up. So you might have to do that, depends how it feels that day. Another thing I need to do is I'm going to bring in my soils data for some GIS. I need to set my coordinate system in my current drawing. So I'm going to right click on the top level here where it says current drawing and hit set coordinate system. Notice I'm under the map explorer tab. You can search for your area. Here you go down to Pennsylvania, USA, Pennsylvania, and then you'd choose if you're in the south or the north zone. So we're in PA 83 south feet. So make sure you choose the appropriate units here, US foot, not meters, US foot, very important. Hit OK. So typically it's going to be PA 83 SF or it's going to be PA 83 NF for us. Usually we're using feet and we're either in the north or the south part of the state. We're usually on NAD 83. If you memorize that, you can just type that in there. Next thing I'm going to do is I'm going to attach my soils drawings from our W drive. So I'm going to right click on drawings here, hit attach, go to my W drive, go to PA maps, or AutoCAD maps, I'm sorry, AutoCAD maps, GIS project, DWG, and under here, the county I'm in is Berks. So I'm going to look for this UTM 83. Really, I'm looking for soils Berks. I'm going to hit add and hit OK. So that attaches that drawing. Really don't see anything happen on the screen here. It's almost like bringing in a data reference. It's in here for data's sake. It's not, doesn't bring anything. It doesn't load an XREF. It doesn't see an image or anything like that. The next part I want to do is query in some objects from that map. So I'm going to double click on current query. If there's anything in here, this location, just hit delete. We want to clear that out and hit location down here again. I'm going to do window. Circle, whatever you'd like, and a crossing window. Hit define, and sorry, do the end here to here. And I'm going to hit the draw, not preview or report, draw. Hit execute query. And that's going to bring all the soils in from that are inside or across this square. Okay? So the next thing I'm going to do is I want to pull off or extract the data out of these lines, because they're more than just polylines. If you look in your AutoCAD properties dialog here, you can see it has the soil type associated with the polyline. It's called object data, and it's attached to the polyline describing what that soil type is within that area. So I need that to be sort of sucked off of that polyline and put into a little symbol or whatnot in the middle of each area. So I'm going to go up to my Civil 3D pull down here, go to Map, Tools, and hit Create Centroids. It's asking me all the objects. Really, I'm going to hit Select it only. I'm going to come to this Q-Select dialog, hit Layer, and tell it to operate on all the objects on my 00 soils layer. Okay, tire drawing, multiple layer soils. Hit OK. It's asking me where do I want to put these little centroids, and you'll understand what these are here in a second. I'm going to put those on my 00 soils centroid layer, and hit OK. And you'll say, I didn't see anything happen. Well, it put in AutoCAD nodes. So TD mode is the command, and you want to change that AutoCAD variable to 2. So now you can see these big great crosses on your drawing. I can use PD size, and I can set that to different values, maybe 20, and then that will do a percentage or a hard-coded value of my screen. If I have the PD size set to 0, when I zoom in, hit regen, they'll get smaller. If I zoom out, they'll get bigger. To make these a little easier to see, I do want to adjust my layer, and I'm going to change that 0 soils centroid layer and make that yellow. Then the next thing I'm going to do is I need to bring these soils into my little area here. So what I need to do is sort of refine these soils, and this is a very difficult part of this procedure. This is where people get bound up. That little message, I need to detach my map from the W drive. So I figured out a way or a workflow to do this as easy as possible, and let me show you what the next step would be. These little dots I need to move in to be inside of my rectangular area. But it's not that straightforward, because some of these dots, like this one, actually has to be here and here, because you can see that boundary comes in. There's areas inside on either side. It's actually up here as well. So you have to go around the entire perimeter and do that. And really what you get messed up with is when I click this polyline now, since I ran that centroids command, create centroids, it doesn't have any more object data assigned to it. So how do I do this efficiently? Well, I can come up to my display manager, hit data, connect to data, and I can connect to the physical shape file that this read to bring these soils in. So I'm going to call this Burke's Soils, and this is sort of a little workaround, but it seems to work pretty well for me. And I'm going to go down to my W drive, and I'm going to go under Certified Soils, and then hit Berks County here. Go into my Soils PA 1101 and Spatial, or State Plane NAD 83, and then which file do I connect to? Well, I hit Details, and I look for the biggest file. Click that. Hit Connect. And then I need to, again, it just connects to it. It doesn't bring anything in or just connects to it for data's sake. I need to actually add that to my map. So I'm going to hit Add to Map. And now you'll see the entire county of soils. So that's great, right? But how does that still help me? Well, I can grab the whole thing and set it to the back, and now I can see my areas here, but it's still very cluttered. And how do I navigate all this? Well, you can come up to this. Notice I'm under Display Manager. I can come up to this and hit Edit Style. Once I pull up the Edit Style, I can come to this little ellipsis down here under Style. and I can change it from green to any color I want. So I'm going to change that to black, and I'm going to set my opacity or transparency to 90%. I'm going to hit OK, and close this dialog here. And now you can see that, no, now you can't see that map anymore, right? You can't see that soils map. But what I get here that's very unique is that if I click in any given area, it still highlights the whole boundary. Really, when I'm clicking that, I'm clicking this object. So still, how does that help me? Well, I can right-click on this now and hit Show Data Table. And I can bring this little table and minimize it up. And whatever area I click on, you can see it highlights the row. And it shows me BKB. This area is BKC. This area is BKB. Again, another one, BKC, a lot of BKBs and BKCs. This one will be different. BTA, so on and so forth. Well, now it gives me like a little legend. So if I'm confused about an area, so I can bring, some of these are straightforward. But for this, for example, this one, you know, I need to put a little triangle in here. Which one? Well, if I click on that, that symbol there, you can see, oh, okay, well, it's this one. So I can just copy these little nodes into there. And this takes a little time. You got to go around. You can see I can take this one up here. Okay, it has to be there. I need to copy this little node also up into here and also down into here. And I can also verify, like, okay, that says BKB. All right, well, let's pull my AutoCAD properties dialog. Let's lock this open. And when I click on the little node object out here, that says BKB as well. Okay, well, that's good. That's important that they match. I can bring this up here as well. Bring this up. You can see this is a big old long one, and actually the node formed all the way down here. So we'll bring that up. And so on and so forth. So take this one, bring this in. Take this one, bring this in, and you just keep going around. You know when you're done? When all these yellow nodes are inside this red square, okay? Have to be inside of it. So I'm not going to go through and do that. It would take another probably 10 minutes for me to do that. I'm just going to erase this. You can turn that, that map thing gets in your way because you can see it's all out here and everything. You can just uncheck it. And then that's sort of turned off. Now I can't do that anymore. I'm going to erase this, and I'm going to insert in one that I had done already. Soils with issues, good. Okay, so what I did there is I brought in, you know, I moved all these nodes in, and then I used a command called map trim. I should have showed that. Map trim. And then with the map trim command, what I did is I hit select boundary, and I selected that outer triangle. Then I hit automatic. I hit filter selected objects. I said layer. I said, oh, you're only going to trim out my soils layer here. I would hit outside boundary and uncheck these two. And then I hit OK. And what that did, so you can refer back to this video if you want to see that. I apologize, I skipped forward a little bit too much there. That trimmed out all my soils outside of that red square. So you end up having what I have here. The next thing you need to do is you need to clean these soils up a little bit. So I'm going to type another command called map clean. And this is just a workflow process. Watch the video to follow it again or replicate it. And this map clean will actually, when these soils are brought in, they're closed polylines, and they're overlapping each other on the edges. And very similar, and it's not coincidence, very similar to Civil 3D parcels. You cannot have overlapping lines on the boundary. Like this boundary line here cannot have, you know, a polyline for this enclosed area and then another one to outline the enclosed area over here. You can't have that. It has to be its own independent line. So there's only one line here, very similar to a parcel. Parcels are like that because parcels in the background are AutoCAD map topologies. So I'm going to use my map clean, and I'm going to hit load here, and I'm going to browse out to my R templates topologies directory. So everybody should have this. Go ahead and do that and hit create topology, 1 foot tolerance. Hit OK. I'm going to say, well, what layer do I want it to act on? Well, again, seeing a pattern here, I only want it to act on my 0 soils layer. That's essentially it. Just there's a bunch of settings here, but they're set with that load. Just hit finished, and it will go through and have like a gazillion errors. It will create a whole bunch of objects and delete a whole bunch, and you just need to keep running that. All right? And you just keep running it and running it and running it, and hopefully you'll get to a spot that says 0, 0, 0, right? In this drawing, that's why I loaded this, because it's a little problematic. This still has issues with it. So I have, really to make a topology of this, I need this to say 0, 0, 0. Why doesn't it say that? How do I know where to go? Well, I'm going to let the error checking for creating of topologies to show me that. I have another question here. To write the mail, what else? Okay, yeah, good point, Karen. I'll make sure to cover that. There's also a whole process Karen Griffin in our Lancaster office wrote up on how to do this whole process, and I'll highlight that at the end here. So I'm going to go ahead and try to create a topology of it, see what happens. So I'm going to go over to my Map Explored task pane here, go down to Topologies, right-click on it, hit Create. We'll call this Soils, right? And that's important. You can't call it whatever you want. It needs to be called Soils. Don't deviate. Soils. And links. The links are, there's a little terminology thing here. The links are essentially the line work. So the links, select all objects on my 0 soils layer. Going to skip all the way down here to select centroids. You can skip the node part. Centroids are these little yellow dots. We put those on our 0 soils centroid layer. Okay? And I always have to remember, and do not forget this, this is very important, to always come in here and uncheck create missing centroids. You don't want it to do that. Hit finished. And you can see intersection detected, cannot create polygon topology. Hit close. So I get a little circle. And what's happening over here is if I'm zooming way in, there is a little piece of another soil that I didn't see and don't have a centroid in it. It's so small, I don't care about it. I'm just going to erase that little area and bring this polygon up to the top here. And why it didn't clean that up properly is because that little piece was less than a foot in length. You can see when I did a distance command there, we're talking about a very little bitty area here. So even if I did add that, that's going to really have no effect on my drainage characteristics. It's probably even the same soil group anyways. So go back, and I'm going to run my map. So if I change any line work, if I edit any line work whatsoever, I have to do map clean again. Now it's real simple because it saves all the settings, so you just type map clean and hit finish. And now you can see I get 0, 0, 0. What I want. So now I'm good to make a topology. Right-click on here, hit create topology. Saves all the settings here, but you always have to remember to go down to create new centroids and uncheck the create missing centroid. Everything else it saves. You can see the centroid layer it saves, the link layer it has in there still. Hit finished, and I still have problems. So what's my issue now? Well, you can't have multiple centroids in the same area. See this area through here? And I can go back and use my handy-dandy highlighter here. I have this one area. This is a certain soil type, probably a creek coming down through here or something. And I have a centroid here and here. Well, that's no good. Let's bring up our data table again. We're going to use this. And what is this soil? Well, it's a BTA soil type. Well, this centroid is BTA, and probably the other one as well. I made a mistake. I copied a centroid too many times. So all I need to do is erase one of those. This centroid, you can see this soil type is a perimeter and surrounds a 1 inside of it. So when it made the centroid, it actually didn't place it in the area it needs to be. So I'm going to take this and move this out here. And in this situation, well, I'll let that go. I'll let that come up again. So that one looks okay. You can see I missed an entire soil type here. So what soil type is that? Well, I missed bringing extra copy down. So I'm going to copy that one up here. Bring it down to here. Okay? And that one's that one. And then we don't know why that's happening there. So why is this one here? Everything looks okay. Well, it's again this whole big surrounded area. Actually put a centroid, and if you hit the move command and move one of these, they're actually 2 on top of each other. So which one's right? Well, I'm going to click on this soil type. This is supposed to be WED. I'll click on that little centroid there. That is a BKC. That is not what we want. So I'm going to erase that one. Double check, make sure this is a WED. Yes, it is. All right, and then up here, again, missed another one. So it's actually the same as this down here. Copy this, place it up here. And then skipped ahead. I use that example, but this one had that same problem with the 2 centroids. CPA, it's probably this one. Nope. So that's the one I want to erase there. All right, so let's try it again. Let's make us topologies. Create. Go down and create new centroids. Uncheck it. Hit finished. And cleaned everything up except for right down here. I missed this one. So this is a BKF. So I'm just going to copy another centroid thing here and bring it down here. Now, I don't know if that's necessarily BKF, but I can click on this one, go into my properties dialog, and I can make it a BKF. Hit tab. So now that centroid's object data is BKF, just like the soil type. So that this map, this whole display manager and using this map, you can see how very handy that comes in to figuring out what's what and making sure you keep things straight. I think at this point I'm in good shape. Let me try this one more time. Create missing centroids. No. And I'm in good shape. That is essentially the hardest part. Getting these, because this line work has to be perfect. It can't have, you know, overlapping boundaries and the one end missing the other. It has to be perfect. The map clean takes care of most of it, but you know, and creating the soils is probably the hardest part as well. So to save on some time investment here, the rest of this I already have sort of templated, so I'm going to have to do the same. Make a topology for my my pre-cover, which is all this area within my permit boundary. So my soils, I really overshot the whole project. I didn't need to be so large, but it doesn't hurt. Probably took me an extra 10 minutes to get that. Now I know I have it if I need it for anything. This is my pre-cover, and you can see I'd have to, you know, get creative and copy line work in. What I recommend doing is going into your existing conditions base file and doing using the AutoCAD copy base point, and then hit paste to original coordinates, and just copy in as much line work as you can, and place it all on the same layer. Place it on 0, cover, pre, and then you have to put little impervious symbols through here and so on and so forth. If you want more details on this part, you can watch Streamlining Stormwater Analysis. It was a lunch and learn we covered. Talked about that, and there's some CAD training back in 2007, January. I'll highlight that if I get a chance here. If you have questions, give me a call on this part, but it's essentially the same thing I did for the soils. So there's my pre. I'm going to load that topology. I'm going to also insert the rest here. And there's my post cover. So my post is pretty simple. That's the design. So I'd steal line work from the design file and bring that in here. This is all my little units laid out, which is not necessarily in the design, so I had to put that in here. and my permit boundary. Okay. So now I have all these areas, and let's look at our overlay and what we're going to have to do here. The post I'm really not going to work with right yet. For the pre, this is my permit boundary. For effect, I'm going to go the full size here for everybody to do my pre and post matchup to get my volume that I need to infiltrate. So I need to overlay this area with all the soils, with all the different covers, which is a big task. It's a lot of tracing around polylines. And it will take a good amount of time, and you're not building anything. Granted, making this pre-development, I didn't really need to actually do all this. All I really needed for my pre is within this area here. That would still take some time, but not nearly as much as it would to trace all the soils out. And then if anything changes, I have to do it again, especially in the post condition. So you save a lot of time, and these topologies are used further and further for stormwater analysis, cover analysis of your site. So you know, an hour will benefit you 10 on the backside, where if you're just tracing around by hand, that 4 hours that you spend you can't really leverage that in the future more, where topologies you can. So I'm going to load this cover analysis here. And I want to browse out now to my R AutoCAD, or I'm sorry, R templates topologies directory. And under there you will find a PDF called Topology Conventions. So go ahead and open that up. And in there you will see, how did you know to name the soils topology soils? Because it says it right there. And you must follow this. This is not optional. If you don't, none of this is going to really work. But really what I'm interested in, so these are the topologies you're going to make. And you can see how we use it for post-stormwater and inlets and BMPs and determining all the different areas that go and breaking it all down, so it's used heavily. But really what I want at this point is I want my topology overlay conventions. So I'm going to overlay all this stuff and use templated overlay templates to quickly do that. So I'm down here, I'm under MPDS with soil. So that's my first step. So really just come in here and look for MPDS. The first thing I need to overlay is my MPDS over soils. So, and how this works is, since it says MPDS here, I'm going to right-click on MPDS, hit Analysis, and hit Overlay. Okay? And I'm going to load. And how do I know which one to load? I'm going to click 8 here. Same location, R, Templates, Topologies, Overlay, Template number 8, hit Open. And how did I know it was 8? Well, right here. I'm going to right-click on MPDS, I'm going to load 8 and verify that it's overlaying with soils. So I'm going to hit Next, and just make sure this changes to soils. Essentially there, I'm finished. So that did an overlay analysis with my area, and you can see the white line now, and it broke it down for all different soil types. So you can, if I isolate that, you can see it broke that down. Made new centroids, makes a whole new topology. Now the next one I'm going to do, it made this new topology here. I'm going to right-click on that one, hit Overlay, or Analysis, Overlay. And that one's going to be 9. You'd refer back to the sheet. I just know it's the next one. It's 9. And verify that that is overlaying it with the pre-cover condition. So now it's going to break my MPDS boundaries / soils and break that down per pre-cover. Hit Finish. So now you can see I get quite a bit of breakdown in areas there. Well, that's it. You're done. You did the hard part. That was the tracing around polylines. So I just need to get this data exported out of Civil 3D now. So I'm going to right-click on my Civil 3D pull-down, go to Map, go to Queries, go to Run External Query. And we've also templated this for everybody. Go to R, Templates, Topologies again. And these are my exports. I'm going to use my MPDS soils pre-cover. How do I know to use that one? Well, it's the same. It's whatever's the same name as the ultimate topology you end up with. Hit OK. Your computer chugs along and it pushes stuff out. And it's going to push that out. Yeah. It's going to push that data set out to your Xshare location. So this will be in your local office. And you can see I have this MPDS soils pre-cover. So everybody's pushes to this same location. So make sure at this point you copy this and paste it in your project directory. So my project directory is a little different because it's training. I just have it on my C drive. I'm going to make a folder in my project, probably under the permits folder, MPDS in my P drive project, to do this MPDS stuff. And I'm going to make a folder called pre-MPDS. I'm going to paste that data set in there, which I already had. Another thing I need to copy out of this topologies directory. Let me get back to that. Where is it? No, it's right here. This is the R templates topologies directory. There's this HydroFlow/HydroCAD compression worksheet. So just copy that out of that directory as well. Notice everything that you need is in this same directory. It's like one-stop shopping. It's all here. And paste that into, your P drive project and rename it to pre-MPDS. Now it's important that this is in a pre-MPDS folder, and you'll see why here in a second. So I'm going to open that worksheet, and it's an Excel file, and you must enable macros, and this is it. We use this a lot for all kinds of stormwater stuff. That's what this is for up here. But right now we're just going to use it for MPDS, boundary determination flow characteristics. One thing I do need to fill out is these red tabs. So the first one is my soils data. I've taken the liberty to do that. So you need to come into here and put in your soil types and your hydraulic soil group characteristic or code there in C, B, or D, or A soil series. So go ahead and fill that out. Once that's done, I'm going to go over here and hit open. And I'm going to actually open that text file. So I'm going to browse to my temp directory here, my project. Again, this would all be on the P drive at this point. I'm going to open that MPDS soils pre-cover. Hit open. I'm going to hit next here. This is a comma delineated file. So click on the comma. Hit finished. And you can see here's the breakdown. So there's 85 different types of areas, or 85 polygons I would have had to trace around to really actually get this correct. It's real simple here. I'm going to copy this. So I can hold down Control and Shift, click on the last line, hit the right arrow and the up arrow, and it gets everything I need. Hit copy, go to my MPDS worksheet, go to the next tab that's red. I already have this in here, so I'll just clear that out. Go to Map, Import, MPDS, right-click on the top cell here. Since I did too much, sometimes Excel, if you start messing with things, it will clear out your paste. And paste, that pastes in here. At this point, you don't really need to click any of the sort columns thing. You can do that, click sort columns to verify. This should list soil types here. If any of them says missing data, you missed a soils type over here. So verify that. People miss this part about entering the soils, and then they get blank stuff, and they call us and say, why, what's going on? At that point, you're done. Go back to Control Panel and just hit this Update MPDS Worksheet 4 link. Click that button. It runs a macro in the background, basically some coding, and hit OK. Got a question. Are hydraulic soils groups in the certified soils file? I don't believe so. Dan had a question from Lancaster. If I would turn on this data table, because this is everything that would be there. There's a hydraulic soils group in here. No, it's not. To get the hydraulic soils group, I'll show that at the end. There's some websites you go to, but you probably already know that. You're just asking if it's in there already, just for convenience sake. So I clicked that macro, clicked the button, it told me, hey, okay, it did it. So I can save this worksheet now and close it. Okay, close that other temporary one. And what it did is if you go to that same directory that Excel file's in, it created this directory all by itself. And in there, it made an Excel file here. You can double click on that and see what it is. What it is, it's a columnized breakdown of the area, all the common areas that are meadow and soils group B, the acreage in square feet and an acre, the area in square feet and acres, and the curve number value for that. So B meadow will give you that curve value. Woods good gives you that curve value, so on and so forth. At this point, there's another worksheet out there called, go to topologies here, go back to my R templates topologies. I'm really not dealing with topologies anymore. I'm dealing with MPDS. So I'm going to back up one directory, go to MPDS. I'm going to copy this MPDS worksheets Excel file, place that in my project. You can see it right here. Open that up, and that's this initial worksheet I showed everybody with the different tabs here for my sensitive natural resources, so on and so forth. Simply go into my first column here. Hit Before I go into that column, I want to make sure I have both worksheets open. So I'm going to go into this pre-MPDS, go into this MPDS NOI worksheet 4, and go under Site 1 and open that up. You can do is go up here and window arrange and do horizontal if you want. That splits them up. Essentially what I want to do is hit equals and then pick into this sheet and hit enter. So this worksheet's going to read this file's A2 cell. I can highlight on that and go to the right, highlight everything to the right, hit Control R. Oh, sorry, forgot a step. This is another gotcha, is when you're doing that from one worksheet to the next, it puts these little dollar signs in front of the A and the 2 or whatever cell it's looking for. If you remove those, then you can hit Control R, and it copies everything to the right, moves it over, and then you can hit Control D down, pulls everything down. Might have a little bit of formatting to do again, so I'll just highlight all the rows, go into formatting, change the middle row value here. That's what I wanted to do. And you can see here's my site area, and here's my pre-runoff volume for stormwater management. Essentially going to do the same thing for post, and it's really quick. I already have this MPDS soils. I'm going to right click, hit overlay analysis, just following that chart. This one's going to be 10. Oh, I'm sorry. Before I do that, I need a composite cover. That's going to be my pre and post sort of put together. I'm going to freeze these for example's sake here. So what I need to do there is right click on my pre, hit analysis, overlay, load. Using that worksheet, you would see it's 01. Hit OK. Make sure it's overlaying that with the post. Hit finished. That does a paste where it actually pastes my post and into the pre and makes a new topology called post CV complete. Then I'll do my overlay here for MPDS. That's going to be 10. Just you memorize this stuff after a while. And hit finished. And that will give me that. Go up to query, external query, push it out, put it into the post file here. Hold on. You can see it'd make another directory for post MPDS. You take that file, push it out, do the same thing as you did with the pre. Hit the macro, makes a folder, makes a new, another one of these same directory name, same name, and that's why it's important to have two different folders here. And then you come in and just link these up. And that will give you your MPDS volume that you need to control. That's a pretty big part of the project. Really, that's your starting ground to really get all the rest of your calcs going. So if you have questions on that, give me a call. Hopefully I went through that enough that you can handle it for your projects. Did want to highlight some other things to get this done. Karen Giffen in Lancaster office was nice enough to create a whole streamlining stormwater management users guide here, and you can go down through it. It takes you step by step how to bring in the soils. Here's the overlay convention worksheets. You can, or same overlay convention file, and just goes down step by step on how to do this whole entire process. So use that as a resource. Use this video, and hopefully I know it will save you lots of time. The bigger the project, the better. So I'll stick around here for 5-10 minutes, answer any questions online, or you can give me a call, extension 213 in the Harrisburg office. Thanks, everybody, and hope this helps.